My name's Neil Craig. So I work at the BBC and I'm one of our architects. I work in a division which is just about being rebranded into being called distribution or digital distribution. So what that really means is we work on the core services that put the BBC websites and the audio and video like iPlayer and Sounds. They put them on the internet and keep them there in a resilient and scalable fashion. So that means that we work on networking, DNS, traffic management, CDNs, all of those things that you see there. And also I do some work on analytics, and that's kind of what I'll be talking to you about tonight. And it's a system that I've built called BQ Logs. It's a really unimaginative name. So just to set the scene, when I started at the BBC, which was, when was it, 6 years ago? What we did with our access logs, so those are the logs that are generated whenever you request a web page or a program from iPlayer or something. Those logs were basically taken from our traffic managers or our CDNs, and they were basically stored in S3. And it was kind of a tricky system to use. So it's sort of half to 1 terabyte a day. The logs were stored in a kind of big, heavy nested series of path prefixes. So if you can kind of imagine, it was sort of one big long path per traffic manager. So at that time, we had 8 front of house traffic managers for the website. So there were kind of 8 duplications of a big path prefix, and the kind of logs would sit right at the end of those. So if you wanted to get like an hour's worth of logs from all 8 traffic managers, you'd have to kind of dive into each one of those in turn and pull them out and then do the processing that you wanted to. And that was kind of really, really difficult to use, and it was slow. You'd kind of fill up your hard drive. And because it was very manual, it kind of lent itself to being very error prone, which is not a great place to be when you're kind of trying to use data and be data driven and make good decisions based on that. So after a little while of kind of wrangling with this stuff, I got a bit fed up and decided that I was going to do something about it. The tricky bit was I didn't have an ops or an engineering team to work with, and had very little budget. So I couldn't sort of just buy a solution. So I did what a lot of us do and decided to build something. So what I'm going to do now is just kind of give you a bit of an overview of what that's kind of evolved into. There was a brief proof of concept to check that this thing was going to work. And then it kind of morphed into a system that we use now, and we've used for 1.5 years or so. So as with any sort of system design, you start with a set of requirements. So my sort of main ones were the system had to run and to scale itself up and down autonomously. This is really driven from having no ops or engineering team. So it was going to be me running this. So I needed to do everything for itself. The scale that it operates at, for a bit of context, is sort of 2.5 billion log lines a day, roughly. And the peaks that we get across a range of services that this covers are into the hundreds of thousands of requests a second. So each one of those requests, as I said, that will generate a log line. So when times are busy, you get a lot of log lines. It fills up quite quickly on your hard disks. There are lots of different log sources. So I mentioned the traffic managers. There are actually several types of traffic managers that we have, and different configurations of those for the different reasons of use. So websites versus things that are kind of more to do with the audio and video serving. Each of those has obviously got a different format, because it'd be far too helpful if they were all the same. I needed the data retention to be automated. I needed enrichments to be automated. So that's kind of leveling up the playing field for the various log sources. So some of them are more capable than others. So we need to do some sort of processing time enrichments. One thing which is quite interesting, to me at least, is I was really keen to store raw log lines, because aggregations kind of tie you to having to know ahead of time what it is that you want to query for. And a lot of the uses for these sort of logs, at least in our team, and certainly in some others as well that I've worked with, are kind of ad hoc triage. So it might be a big event and we want to know a bit more about it. It might be diagnosing a failure in something. It might be diagnosing attack traffic. So there's loads of reasons. And having the raw log lines is super useful for that. So I was really keen to get that in there. We want low latency. We want strong authentication and controls around the private data. So in the system, you have to be first granted access to access it, and it's a very closed system. And then you have to pass some extra hoops to get access to the personalized data. So that's things like client IP addresses and that kind of stuff. And then lastly, a really important one is I wanted the system to be easy to use, because it's all well and good having this data in a magical system, but if you have to learn a load of languages and you've got this real steep on ramp, nobody's going to use it. And to be honest, I would probably forget half of it over time because my memory's not great. So what I ended up building was a system which is built around Google Cloud. Other clouds are available. The main sort of reason for that actually was BigQuery. And I won't sort of go too much into that, but the sort of large scale storage, the fast query times, and the amount that it does for you were really important. As I say, this was me running it. I have no one to back me up. So I need this system to do pretty much everything. And BigQuery is really good at that sort of thing. But I'm not going to evangelize about Google Cloud. This isn't what this is about. So let me just sort of take you through how this system works. If we start at the top left, that's the input point. So those are the log files that are arriving from our traffic managers or our CDNs, and they go into a storage bucket. When a file lands in the storage bucket, that will create an event. So that event triggers a cloud function, which is like a Lambda in AWS. And that's what does the conversion. So that will pick up the input file. It does some validation on it and parses it into an intermediary format. Then it does data enrichment and finally converts the data into an output format, which is comma delimited JSON. That's written into the batch bucket. So from that point, we've all sort of been event driven. So log file gets written to the input bucket, gets picked up by the function and processed, output into the batch bucket. And then every 2 minutes, a cloud scheduler, which is basically cron as a service, that runs, triggers the batch ingest function, which looks through the batch bucket, lists all the files out and says, BigQuery, load those in, please. And BigQuery kind of goes and does its thing, does all the processing stuff for you. And basically your logs are available to be queried in probably 10 seconds or so on average. It's that sort of time. The reason for that batch stage is, at the time I built this system, the BigQuery had 2 ingest methods. One is streaming, and that was actually quite expensive at this sort of volume. So I couldn't do that, and I had to use their batch ingest format, which is limited to just under what you could do minutely in logs. So I had to run it 2 minutely. So it's really to kind of work around that system because that's free to use. So that was a cost limiting exercise. So that's all the happy path. If anything goes wrong through that happy path, it's normally at the first stage. So that might be the event got lost somewhere along the way between the bucket and the function. Anything that happens in the cloud, you have to design for failure, don't you? So every 10 minutes, a different cloud scheduler runs, and that wakes up a mop-up function. And its job is literally just to look through the input bucket, look for old files that have been missed or have failed in the convert. And all it does is attaches some metadata to that file. And the metadata is just a loop count, which is a retry count, basically. So we'll try up to 3 times. And when the metadata is edited, that sort of reprompts the convert function, and the chain goes on. So there's kind of basic error handling there. And it works pretty well, actually. It does its job, and it's not often that it's used, but it is certainly used, and we kind of monitor all these things. So that's all good. So just to give you a little bit of kind of stats on the system and how it's going, again, just for a little bit of context. As I mentioned, sort of 2.5 billion log lines each day. So that's across the scope of the logs that it handles. And what that results in is somewhere between about sort of 400 and 650 cloud functions that are running at any one time. So each one of those cloud functions instances is processing 1 log file. So that's sort of roughly our concurrency, a sort of BAU state. Things do get quite a lot busier when there's, when there's big news events and that kind of stuff. And I've certainly seen over 1,000 instances running, sort of 1,600, something along those lines. So it's really nice. That just kind of scales horizontally and I don't have to do anything. So that's magic. There's 380 odd terabytes of logs in there at any one time, and we do about 15 billion log files each year. So that number was quite a surprise, actually. But yeah, I just picked it up in looking at the billing the other day. So you can just see the sort of daily scaling of this is the number of cloud functions instances which are running at any one time. So you'll just see how the load varies through the day. So this is one of those things where, the kind of serverless model is pretty nice because you can just chuck a lot of load at it and it will scale itself and sorts itself out. So that's super handy when you've got no team to look after this. So I'm going to do a little demo. I'm hoping this is all going to work. I'm just going to hop over to a different tab. So you should be able to see the Cloud Console now. So this is the web interface for BigQuery. So BigQuery, just since I didn't explain earlier, is an SQL data lake, data store. You chuck your data at it in whatever format. So we do comma delimited JSON, new line delimited JSON, sorry. And it turns it into an SQL queryable format and kind of does all the indexing and all that kind of stuff for you. So what I'm going to do with this query is just a real simple one. This is a little bit contrived, but there we go. So I'm going to look for top level directory. So we organize our website by the URI, by paths. So /news and stuff under there is generally controlled by the news team, /sport team, weather team, children's team, and so on. So we're going to look at the top level directory. We're going to find for each top level directory how many requests per day there are. So this is looking at yesterday's data just so that we've got a full day. We're going to work out the percentage of it, and we're going to focus this on bbc.co.uk and bbc.com. So let's run this. Hopefully the magic clouds will work for us, and we'll get some results in a couple of seconds. There we go. Okay, so 3.5 seconds to run that query, 18.2 gig that it processed. Let me just move this up a little bit so we can see. So there you are with the results. So you can see that news is the most popular, just under 17% of the traffic. And then there's the homepage is / user info is a kind of internally used endpoint. And then you can see a few others down there. So that's kind of cool. But say we wanted to look at traffic from a specific country. So if I amend this and I find country code, let's go for Ethiopia. So we can rerun that and just look at traffic from folks in Ethiopia and see how the output varies. There we go. So rather than /news being the most popular top level directory, we've got Amharic, which is one of the official languages in Ethiopia. And that's a big old chunk of the traffic from there. Not really a surprise because we've got a specific Amharic news, language service. And now let's say that we wanted to, rather than just look at the number of hits, we wanted to have a look and see, have a look at TLS and see what sort of types of encryption people are connecting to us with from Ethiopia. So let's run that again. A couple of seconds, we should have some results. And no surprises, TLS 1.3, which is the most sort of modern protocol version. That's at the top there. So that's cool. That's all kind of interesting. So what about if we limit that to Amharic we saw earlier? So just traffic to that. I forgot the equals. Hang on 2 seconds. I've got a new keyboard and I'm still finding my way around. Okay, so let's run that. So does that change at all? Yeah, it does. So a bit more TLS 1.3. That's good. And then a final contrived example. Let's have a look and see whether users of Firefox are any different to the sort of the average of folks from Ethiopia hitting the Amharic top level directory. We'll run that one, and hey, oh, look, there you go. A bit more TLS 1.3 for Firefox users, nearly 90%. So that's kind of cool. All right, I'm going to jump back to here, and actually, I was going to do another demo. Let me just show you another super quick one. So one of the other cool things that you can do in BigQuery, and another reason for using it, is it's got a load of built-ins. So we could do quantiles. So in this case, what we're going to do is We're going to look at, again, BBC Co UK and BBC.com. We're going to look at GTM, which is our internal traffic manager service. So this is an in-house system, not a commercial CDN. We deploy that into regions. So we got a couple of regions in the UK. And what we're going to do is have a look at how long the requests take inside the traffic manager. And we'll compute a 50th percentile, so the mean, and we'll compute a 95th percentile of those for yesterday, just so we've got a full day's data. So let's run that one. That may take just a touch longer, perhaps. Oh no, that was pretty quick. So there we are. So you'll see some of them there. And so these are the 2 UK regions that we run. And so, yeah, we got some nice data there. So that's pretty sweet. And BigQuery kind of handled all that stuff for us, which is nice because I don't want to be having to manage the code that kind of computes that sort of stuff and having to think about what it is that people are going to run. People can just write their own queries, so that's nice. All right. A layer on top of this is visualization. So I'll just have a real brief run through this. So we take that BigQuery data, there's a periodic Lambda that runs, and that pushes the queries that you define into Influx. So these are aggregations. So they're ahead of time sort of thought about visualizations. Run through a couple. So there's one, this is a percentile, just as we saw a moment ago. And that's looking at the origin response time. So that's the time from a request hitting our traffic managers or the CDN and that fetching the content from the back end. That's what that time is. So that's looking at I forget which percentile, and plotting it against the number of requests per second. So what we're looking for is for that to stay fairly flat regardless of load, obviously to a point, but that's kind of cool because that is fairly flat, so that's nice. We've got geographic data. It's truncated, it's not accurate, but it's accurate enough to plot by country, so that's cool. We can see where the folks that are using our website are coming from in the world. We do things like monitor the cache hit ratio because obviously our edge services are aiming to take off the bulk of the load and protect the origins. So anytime that offload drops below a certain percentage, we throw an alarm and we go look at what's gone wrong. Happens very occasionally, and obviously we want to know about it because that can affect service. And just the last thing I'm going to mention is we've got what's called a reporting endpoint, and that sits effectively in front of BQ logs, and it's another input to BQ logs. So as well as the traffic managers and the CDNs, it's another input. And what that does is it takes reports from users' web browsers. So it's using the standardized reporting API and a few other friends. So we get things like notifications of JavaScript crashes and deprecated APIs being used and that kind of stuff. We also get network error logging, so that's really cool. That's something which came about a couple of years ago. And it's a mechanism by which a web browser can cache a reporting endpoint location, so it's a URL. And anytime after that it encounters a problem trying to get to our website, so if there's a DNS failure, TCP failure, TLS failure, an HTTP failure, it can log that error against our endpoint, so we know about it. So even if we completely nuke our DNS by accident, we can get alerts to say that that's happening. So that is super cool, and that's filled a gaps rather that we've had in the web ecosystem for a long time. We also get CSP, content security policy reports. So that's the mechanism by which we can define what a page can and can't do, such that if any malicious kind of script or code gets into the page somehow, we can set some boundaries on what that can do. And we also, this is the newest edition, is we monitor some of our sites for core web vitals metrics. So this is Google's initiative to boil down a set of metrics. So there's about 4 or 5 metrics which aim to describe facets of whether your web page is doing well or not in terms of its performance. So that's been really cool, and I'll perhaps show you that in a sec. In fact, let me show you that now real quick. So here is one of them, and so this is a Core Web Vitals output for our news website. So that's pretty cool, and that's for folks in the UK. So we get these 4 metrics across the top, and Google have actually defined a set of thresholds which say whether you've got good, moderate, or poor performance. So that's quite nice to know. And we could see if I swap this to, where do we have data for? Let's look at Germany, and let's look at, there won't be much code.uk traffic in Germany, but let's look at our queryable.com homepage. Oh, not much in there either. Let's look globally instead. So you can see that there's a cumulative layout issue on there, but the rest is looking reasonable. Don't know why that's orange. Okay, let's hop back. All right, so that's pretty much wrapping up what I wanted to talk about. All I'll do is just describe a couple of things which I'm looking to do next with this platform, with the BQ log system. So since I built the system, streaming inserts have become a lot cheaper. So I'm just working on using those at the moment. And the main reason for that is that will chop out about 2 minutes of latency between a request hitting our traffic managers or CDN and being queryable in logs. Currently it's 4 to 5 minutes, so I'm going to cut that down to sort of 2 or 3 minutes. So that's quite nice. I'm going to do some better user agent parsing. So one of the things you saw me pull out was a field called UA name. So that's an enriched field, and it parses the long user agent string, and it chops it out into kind of more queryable elements. So you get the web browser name like Chrome, Firefox, Safari, that kind of thing. I want to do that as well for TVs, because we have some endpoints which are used by TVs for iPlayer. I want to do it for crawlers and bots and monitoring and stuff, so that we can easily isolate that traffic by queries. Just saves a lot of legwork in having to write regular expressions and stuff. Possibly porting the system to Cloud Run. There's some optimizations to be had there, so that's mainly a cost win, so that should be good. It's got a bit of a side benefit in potentially being a little bit easier to test locally, as it's container based and I could run the whole container locally. So that's quite cool. And I've always kind of had a bit of an aspiration towards open sourcing the system. So potentially the reporting endpoint that I mentioned. And I'll have to go through the process, because whilst we do have a good history of open sourcing work in the BBC, there are some guidelines, some boundaries around that, which is essentially that we can't open source something which would be which could ruin commercial opportunities. Because we're funded by the license fee. I work in public service. We can't then do commercial companies out of income by open sourcing something which could affect their commercial opportunities. So have to be careful around that, but I'd be quite keen to do it, and a number of people have asked me about doing that in the past, so I will look to do that. I need to tidy the code up a bit as well, because it's a little bit kind of, you know how internal projects get a bit too coupled to a couple of things, so we'll look to do that.